Okay, so hi Jeff. My name is Matt Romagna, and for my final project, I decided to do an NHL prediction model. So this model will read in advanced stats from a site online and through various functions and algebraic methods will generate a prediction on who will win between two teams that night. So it's going to give expected score and the expected percentage to win for each team. So why I chose this topic, I'm a huge hockey fan and sports fan alike, and I love technical side of sports. Always love being knowledgeable in sports, and nowadays there's a huge emphasis on analytics in sports when making decisions, whether it's GM, the coach, even the fans. It's just become a huge part of the sport, and now it's undeniable on how influential it is in making decisions. So. Throughout this class, I found a new interest in coding thanks to you. Ever since we did that one code where we were making a calculator in week 1 or 2, I was hooked to the feeling of completing a code, troubleshooting it, and it finally working. So when I knew when you presented that we would be doing a final project, I was very excited and hoping to intertwine my two passions in making this model. So. Also, creating models like these, and if you make them accurate enough, can get the attention of teams and Las Vegas odds makers. So finding kind of a niche career in sports and coding would be a dream job for me. So hopefully, if this code goes well, and I can continue to make it better and maybe get some attention of some people. So my research question and kind of what I was exploring with this model. So. Once again, analytics are taking over the sports world, and teams are becoming more aware, and they're looking for very predictive models in order to influence their decisions and leave it less up to human error. And one example of people who are using models like this, Las Vegas bookmakers, people who make lines for betting, are making billions every year off their predictive modeling skills, and they're always trying to find the next greatest model to acquire and add to their models. So hopefully I can break into the industry with my model. And sites like ESPN, NHL.com, Fox, CBS are all using models to show fans what their team has a chance of winning, yet I think they're basic and outdated. So my goal is to develop an NHL model that predicts exact scores and winning percentages for that night's game, with greater precision than the models out there. So this is just kind of an example in the bottom of what they're showing on ESPN, just chance of winning for each team in their matchup. So getting into how my model operates, it's a little complicated and there's a lot of algebraic methods to it, and that was kind of part of the problem in trying to solve it. So I'll get into it real quick. But the variables I use in my model and what are, I believe, indicative of winning teams in the NHL. So for starters, for the offensive stats, there's expected goals for. This is just the expected number of goals a team's going to score in a season. This is, of course, indicative of winning, score more goals, win more games. That's kind of the emphasis on there. Expected rebounds for. So the more rebounds you generate, the more likely you're going to have second chances and ability to score goals. So that's always indicative of winning teams. Shots on goal, you can't score if you don't shoot. So the more shots on goal you have, better teams have more shots on goal, and the more goals they score. So the last one is expected high danger goals for. It's where shots and goals come from around the net. So in areas where you're more likely to score, if you generate more goals in that area, you're more likely to win games. And all of these are mirrored by defensive stats, and only difference is these are the against. So the higher for offensive stats, so the higher goals for you have, the better the team you are. The higher goals against, of course, the worse you are, and all these stats alike. So, and the last component of this is goalie stats. So for goalies, one of the most indicative stats of a good goalie is goals against average. So I decided to use a predictive stat of expected goals against average per game. So how many goals they let up are expected to let up per game. So the math behind this predictive model It's a bit complicated. I'm going to run through it, but I don't expect, of course, you to always get every single thing because it's a little complicated. So I'm going to take all these predictive stats and compare them to the league averages and then find the mean of the advantage of each stat. So I'm going to take, so in this case, this is a piece of my code example. The H is just home, def is defensive, and then strength is SDR. So this is the home defensive strength, and this is how I calculated. So I took each variable, compared it to the league average, which is the second variable in this case, and then I added them all up and then took the average of them against their league averages. And in order to find the expected score, I took the home team attacking strength times the away team attacking defensive strength, and then times the league averages of goals per game. And as you can see in the example, it's a little more complicated than that. You take the attacking strength of the home team times the away defensive strength times the average goals for per game of the league, and then you subtract that by a goalie stat, which would, so it is the expected goals against per game for the goalie. And I didn't want to make this too indicative because goalies always play different every night, so I made it 20% of that value to subtract it by. This is only a small subtraction to the overall game score. And then the addition part of this would be the power play strength. So this is when a team is up a man in hockey. And then the penalty kill strength is when they're down a man. So this is just whenever they get a penalty, the home strength times the defense's ability to kill off that penalty. So for the Poisson, so you take these expected scores and you put them in a Poisson analysis. A Poisson analysis is used to model the number of events occurring within a given time interval. Before this, I had no idea what a Poisson analysis was, but as I looked into how models are made, this was an integral part of it. So basically what I'm doing is I'm taking the number of times the expected score appears in a given game. So whatever is calculated for the expected scores, I'm seeing how many times it would be in a given game. So this will be better explained in a table that I will provide later, but you take the generated expected scores, see the probability they would occur in the various scores of the game, 0 through 10. If I put the limit at 10 because most times teams don't even score up to 7 or 8, so 10 is the max there. And then the model will add up all the percent chances when the home team wins plus half the times the teams tie, and when the away team wins plus half the times the teams tie. This will be later explained more when I look in at my model. But here's the code in action. Okay, so now we're in the terminal. I'm going to open up in VI real quick just to show you an overview of what is going on in this code. So at first, it's going to prompt the user input. So it's going to prompt the user to put in the home team, the away team, the home goaltenders, and the away goaltenders. This is all exceptions to that, and it will put it into a form, an abbreviation that can better be looked up in the database. These are all the databases. They are data frames. They essentially are breaking down each team into 5-on-5 scenarios, home and away scenarios. When you input the score, or if you input the team, it goes into here and then sorts this database into just the home team stats. These are all the variables. These are all the strengths and how they're calculated as I went over. The expected score is right here. This expected score is put into a Poisson distribution, and then this is ran through that distribution, and then this is how it is added into the home chance and away chance, and then created into a percent. And these are all the scatter plots that are looking at different variables, but I'll go into that later. All right, let's run the code here. So it's going to prompt with home team. I'm just going to put in the Bruins and say the Penguins, 2 random teams here. And then I'm going to put in the goaltender for the Bruins. This is one of them. This is another one for the Penguins, and then it's going to spit out this and some plots. So it's going to show you the expected score. So it says it's going to be 3-3 Pittsburgh and Boston. Boston obviously has a small advantage there with the .29, but that'll come in later. And then this is a table of the Poisson analysis. Essentially, what this value is the chance that the Bruins score 1 goal is that. The chance to score 2, 3, 4. 10 is obviously the lowest. The chance to score 10 is a lot. 3, of course, is the highest because it was expected in the model. And the same thing for Pittsburgh. It also gives you a chance to win. So for Boston, it is a 51% chance to win. For Pittsburgh, it's a 48% chance to win. This is just all these probabilities added up when they're winning. So whenever Pittsburgh has a 2-1 lead or something like that, it will add it into this percent. Then these plots that are generated are goals for versus expected goals for. As you can see, they're labeled by, if you're good, you have expected goals for and goals for both going for you. If you're bad, you have nothing going for you. And if you're lucky, you have more expected goals for, but less goals for actually. So once again, this is goals against, is the opposite. All these are generally showing a positive correlation between the two variables, just to support why I chose each variable. And then this is goals for versus expected shots on goal for. This is once again showing positive relation. One thing I wish I could have done was put each dot with the corresponding team. I tried to annotate it. I looked all over the internet for codes to annotate. They all didn't eventually work out. Some little problems just wasn't working out. So that's one of the future directions I will want to implement. Okay, so that was the code in action. Now I'm going to go a little bit more in depth to each piece of the code. So the results and output of this were, as you can see, it prompted you to put in a home team, an away team, a home goalie, and away goalie. So it takes that input, puts it into a data frame, makes a data frame of just the home team stats, just the away team stats, just the goalie stats, and the away goalie stats. And then it runs it through that algebraic method that I showed earlier to create an expected score. That expected score is then put through a Poisson analysis to show the probability of that score happening in a game. So a 0 through 10 game, I guess. As you can see in the table, 3.0 is obviously the highest because it's close to the expected score. Well, 10 is not very probable at all. For the chance to win for each team, it is the probability of them winning added up. I'll go over that a little bit later when I look at the code. But yeah, so the scatter plots are just showing a correlation between goals for and expected goals for, or the expected stats. It's just showing a positive correlation in this case. I was hoping to mark each dot and annotate each dot with the team names so you could see exactly which teams are in the good section, the bad section, the lucky, and the unlucky. However, after looking everywhere online, I couldn't find out a way to do it. Every time I implemented it, it didn't work. So I have a lot of scale code in my code for it. So hopefully in future directions, I can add that in. Once again, goals against versus expected goals against, showing a positive correlation. This is kind of just showing support for why I picked these stats. They're pretty indicative of the actual numbers. So the section of the code I am proud of. One is the user input system. It's a little bit more advanced than the one we did with the calculator early on. My user input system takes that user data and many other exceptions to their input and sends the input to sort into multiple data frames. So going to kind of data frames, I was pretty proud of this. I know you taught it in one of the last 2 lectures of class, and it was a big part of my model here. I took a large data frame at the top broke it down into kind of the variables I wanted. So those variables I was talking about earlier, the goalie variables. Then I broke it down into situation, so all goalie stats, and then the power play, penalty kill, and this general 5-on-5 stats. Then I broke that down even further to the input stats. So if you put in the home team, it would sort that home team. It would look for the exact name of that team in that column and make its own data frame, just so I could condense the data and pick from a smaller amount of columns and rows. So the Poisson analysis, I alluded to earlier, kind of how it works. So it takes that expected score that I generated and finds the probability of them. So every time the home score, the probability of the home score is greater than the away score, it puts in the home percent. So I is the home score and W is the away score. So if it was greater than W, it would put into home percent. If it was less than the away score, if the home score is less than the away score, that'd be a loss for the home team. So the away percent would get that. If they're tied, it would take it into the tie percent. And then it would loop all the way back until finally W was greater than 10, it would break. And so then in the calculation, it would take the home percent plus half of the tie percent, because they split the half of the tie percent, and then multiply it by 100 to make it a percent that we could see. And then same thing for the away. Some of the challenges I encountered during this model was just the multitude of rows and columns of data I had to sort through. A lot of miscellaneous data that I didn't really want, so that's why I put them into smaller and smaller data frames. But overall, it was a big challenge for me. Keeping track of all these variables and data frames and whatnot was probably the biggest challenge. Little names that like name differences that I would put into an algebraic expression that wasn't the name of the variable. It was just tough to keep track of all those errors. So, and also organizing my data into the data frames, once again, I said it was tough, but it helped me really compress my data and read the code. So, also, lastly, combining that while and if statements in the Poisson analysis right here was really tough. There's a lot of different syntax errors and constantly looping things that weren't exactly being obeyed. So that was one of the biggest problems I encountered. Some future directions that I hope to take with this model is some auto-updating stats. So originally in class, I wanted to take the stats directly from the website, and when the website updated them, it would update in my model. However, some issue arose with the website where it was like cryptic or something and wouldn't allow me to take it from their website automatically. So I did have to use wget, which is fine for this case, but hopefully in the future I can figure out how to take it straight from the website. I also like to add a player-by-player component to this model, basically being able to look player by player to see how they would perform on the ice, see if they'd score a goal or get an assist or just overall success on ice that night. I'd also like to be able to annotate my scalar plots I mentioned earlier. I'd like to see which teams are in the bad, the good, the lucky, the unlucky. That'd help me advise me on my model and seeing which ones I'd want to pick that night. If they're a lucky team, maybe they're not going to do so good another night than they did before. Lastly, I'd also like to update my user experience. Just overall making the model look professional. I'd like to update it to my website and make it look kind of friendly for the user. So once again, I just wanted to say thank you so much for teaching me in this class. You really helped me through a lot of these codes and a lot of problems I had, and it made it so enjoyable, and I was able to make this that I'm actually going to use for years to come, and hopefully I'll develop it into the point where I can make some money off it, maybe sell it to some teams or whatnot, maybe kickstart a career. But I really found a new passion in coding. So thank you so much for teaching me, and hope you have a great rest of your career, your life, and yeah, thank you.